Hey folks, welcome back for another episode of Code Club. If you have been following in the last several episodes, you know that I have been trying to recreate figures from the W.E.B. Du Bois presentation at the 1900 Paris Exposition. All of these figures have been collected and commented on in this great book that you can get from Amazon for about 20 bucks, titled W.E.B. Du Bois Data Portraits Visualizing Black America. This was edited by Whitney Battle-Baptiste and Britt Russert. It's a great book, and it's really just fun to be able to look at all of the different visuals as well as their commentary on it. All of these figures were handmade. They were painted with watercolors. A lot of the fonts that you see are fonts that are actually drawn. Some of them are printed, but much of it is actually hand-created and hand-written. It's just really beautiful. And a lot of the visuals, to me, are jarring because these were made in 1900, right? So that's 125 years ago. And their sense of style and ways of presenting data is just very different than what we do today. I think part of that, from what I understand, is intentional, right? So if you want to draw someone in, make a plot that looks like that, right? It's like, whoa, what is that? I need to look closer at it, right? And so there's a lot of visuals in the display from 1900 that you would have seen and just been like, whoa, what is that? I need to check that out. So I am trying to recreate these in R, not because I necessarily want to use these visuals for my own data visualization purposes, but what I find is that by making other people's visualizations using my tools, I learn to use my tools a lot better because I have to think about how would I do what they did. And that has certainly been the case with these Du Bois images because, again, they were making them by hand. They weren't using R or Excel or Python or Tableau or any of these tools that I have at my disposal today. So the visual that I'm going to make today is actually the visual from the cover. I'm going to make this spiral plot. Here it is zoomed in. You can get all of these panels, all of these plates of visualizations from the Library of Congress. I've really enjoyed making the last 5 or 6 or so. I'm afraid this might be the most challenging one yet. I just keep wanting to do harder and harder ones. Anyway, this is a visual that shows the assessed value of household and kitchen furniture owned by Georgia Negroes. And so again, showing the data from 1875, 1880, 85, 90, 95, and 1899. And these are spirals that, interesting to me at least, spirals inward, right? I would have kind of expected them to spiral outward. Perhaps they go inward because they also have this legend here with the years as well as the valuation. And so that would be hard to show on the inside, or if the spirals don't all make it to the end, like they don't, right? It would be hard to kind of show this here with all the spirals ending at different places. So that makes sense. Du Bois also is just great at using color in these visualizations. And so the red to me is the most contrasting color of the different colors that they used. And so that would really highlight that this is the current data, right? This is from last year if this was being presented in 1900. So as I think about how to make this in R, a few things stand out to me. So first of all, obviously, it's a spiral. So I could imagine doing something with polar coordinates using chord radial, where we could imagine having diagonal lines in Cartesian coordinates, and then converting that to polar should give us the spiral type of appearance. But when I look at the legend, I notice it's got the years as well as the valuation, and connecting them is a straight line, right? A horizontal line. I assume these are all straight lines. They're just in polar coordinates. Anyway, but these are horizontal lines in polar coordinates. And I don't know how to mix and match the two. That gets me thinking that maybe I should be doing this in Cartesian coordinates rather than polar coordinates. One other thought that I have is that my initial thought would be, well, let's make these as lines, right? We can make these as lines and we can wrap them around and we can use geometry to do that, right? But if you look closely, you'll notice that there is a thin black or gray edge to all of the spirals. You can certainly see that with this pink one for 1875 as we zoom in here. I can't do that with geometry. Perhaps I could use 2 different line widths, but that's going to get pretty kludgy and pretty messy fast. So alternatively, what we could do is to use polygon, which we used a few episodes back to make those wedges from that fan plot for that other iconic Du Bois image from this collection. And so I think that's what we'll do, is we will work in Cartesian coordinates by mapping things from polar coordinates into Cartesian coordinates, and we will use polygon. So here is plate25.r. This is a starter script that you can get as well as everything else that I'm generating today. Down below in the description, you'll see a link to a blog post for this episode that you can go to and get all of the code. I am starting this by loading two packages, tidyverse and showtext. My goal through these series is to only use these two packages. Admittedly, tidyverse is a bit of a cheat because it is a collection of a whole bunch of packages, namely things like dplyr, ggplot2. Anyway, showtext allows us to bring in fonts external from R. So we have the B52 and Vasserly fonts. If you take these font file names and Google for them, you will find the files that you can bring into your working directory and make use of them. I'll also put a link up here for the first episode of this series where I describe how I got these fonts. The B52 does a pretty good job of recreating the hand-created writing of DuBois and his colleagues that we often see in the titles like we see here. The Vasserly does a pretty good job of mimicking the printed font that we often see for labels or legends like we see here for the years as well as the valuation data. I then have a tibble indicating the value as well as the year. And then I have a save statement using ggsave where I'm saving it to an aspect ratio that's pretty good at recreating the aspect ratio of the image from the Library of Congress. So let's go ahead and load our fonts and packages, and let's start thinking about making a spiral. So if we think about a circle, the X position on a circle edge is the radius times the cosine of theta, and the Y position is the radius times the sine of theta. Okay. So to draw that circle, the theta is going to vary from 0 to 2 pi, right? So 0 basically being positive on the x-axis, and 2 pi being basically what you get after going counterclockwise through Cartesian space. And so 2 pi is the same as 360 degrees, but 2 pi is in radians. All right, so that's a circle. The radius is fixed, but the theta changes. So to get a spiral, it's the same thing, except the radius varies as well as the theta, okay? So let's keep this in mind as we go through, that we're going to have changing radius and changing theta to get our spiral. So let's start with our initial radius. So we'll do initial radius, and let's make that 10. And then our final radius, let's make that 5. So we're going to start at 10, spiral through, and end at a radius of 5. So thinking about our thetas, our initial theta, again, is up here. And we'll think of that as being pi over 2. And then our final theta will be over here, which again, if the vertical is pi over 2, and then horizontal over here is pi, that this is going to be 3/4 pi, right? And so we'll do 3 times pi divided by 4, right? But that's only going to move us between pi over 2 and 3/4 of a pi, right? We're going to want to have it go over multiple 2 pi rounds, right? Because this is really almost 3 circles of the spiral, right? So we'll have our spiral end at 3/4 pi. So if we started here, that would be pi over 2. This would be 5 pi over 2. And then this would be 9 pi over 2. And so that then we can do, it'd be the initial theta would be 9 times pi over 2. And then what we can do is we can create our radius values. So we'll say radii, and we'll do seek initial radius to final radius. And then we'll do length out equals resolution. And so resolution is going to be another term that I'm going to create that I'll put up here. And I'll make that 1,000. So basically, we're going to have 1,000 steps around the spiral. That's going to be the radii. And let's go ahead and put that down here. Then we're going to do the same thing for the thetas. And so we'll do seek I theta, f theta, length out equals resolution. So let's go ahead and maybe I'll actually move that down here. And I'll move our formulas down to the bottom here as well. And so then we can take radii and put that in place of our r, and our thetas in place of our thetas. So now when we run all of this, we get 1,000 x values and 1,000 y values, right? And we can then think about putting this into a tibble. And so maybe here, instead of assigning it to x and y, I'll make columns x and y. So we'll do tibble, again, x equals that, get a comma in there for a separate column, and then y equals that with a closing parentheses, right? So that gets us a tibble where we can see that it starts with x at 0, and then y at 10, and then it's going to, if I take the last value and then tail that, then we're going to see that it ends at minus 3.54, 3.54. And so that's, if we think of where my crosshairs are here as 0, 0, going out 3.5, up 3.5, that's going to be where that ends. So cool. So we can pipe this to ggplot and the AES, x being x, y being y. And then let's go ahead and do geom path. So I'm going to use geom path rather than geom line because geom line will sort my tibble by x before it plots the data, whereas geom path uses the order of the data as it's presented in the tibble. Cool. So we have our spiral. I'm going to turn this into a function now. Let's go ahead and call it generate spiral. And it's going to take arguments like these, right? And so we'll do I radius, f radius, I theta, f theta, and then we'll do resolution. And I'm going to have that be 1,000 by default, right? We'll go ahead and define the body of our function here as being basically all this stuff, right? And so we'll tab that over, and then we'll close out the body here. So when I load that, it's upset with me. Why are you upset with me? Unexpected thing. Oh, sometimes I revert to other languages when I am programming in R. So I forgot that generate spiral is the name of the function, and I generate a function by using the function keyword, okay? So let's go ahead then and wrap that around, and now it should be happy with me. It is. Good. And then we'll go ahead and grab these arguments and plop them back up here, and then we'll do generate theta. My I radius will be 10. My f radius will be 5, my I theta. So I think actually I'm going to make these default values. I'm not going to keep typing these in. So let's go ahead and remove what we had started there, and then back up here in defining the body of our function arguments. I'm going to make I theta equals 9 pi over 2, and our final theta be 3 pi over 4. Of course, these are defaults. Defaults can be changed if we want, but I think we're probably not going to change them. So again, we now have our generate spiral, and it's upset with me. Repeated formal argument I theta. Oh, that's because I left these arguments in here. Okay, so we'll remove that. And now we have I radius, f radius, and then our generate theta. We can then pipe into everything else. Oh, and I forgot to load the function, I guess. Yeah, I guess I never loaded it after I fixed those arguments. Ah, I did, but I'm using the wrong name here. So instead of generate theta, I want spiral. I need to slow down and think about what I'm doing. There we go. We now have a function creating our spiral. Cool. Now, when I look at the original, all of the spirals are different lengths, and the lengths are proportional to the value, right? And so I'm going to make all of the values proportional to 1899. And so if I know the length of the 1899, then I can scale that to 1.4 million as they have here for 1899. So I'm going to need to get the distance along the length of my spiral, because then when I come back to like 1875 and I find the relative length that $21,000 represents relative to $1.4 million, then I'm going to want to remove everything longer than that distance. Does that make sense? So to calculate the distance, let's go ahead and do a mutate, and I'll do diff x, and we could say diff on x. I'm getting an error that diff x must be size 1,000 or 1, not 999. And I think if I did like diff on 1 to 10, then I get back 9 values, right? And so it's dropping one of the values. So what we could do is we could prepend that difference with a 0, and then that gives us the distance between all of our points, right? So we have 0 and then 0.1198, and then we can see as it goes further that the distance is actually getting closer between each of our 1,000 rows of this data frame, right? So now knowing that about diff, we can then do length equals the square root of diff x, and raise that to the second power, plus the diff of y, that raised to the second power, right? So that will get all the distances, but it won't have that 0 at the beginning, right? So this will give us an error that it's 999, right? So what we need to do then is add in a 0 on that. And so we basically got what we had before with x, because our differences in y are so small, okay? But this is the distance between each of the 1,000 observations. This isn't a cumulative length, right? And so what we can do then is cum sum on all that. And so now what we get is the cumulative distance starting at 12 o'clock, right? And so then if we tail this, we can see that the full spiral is 88.5 units long. And so we'll then scale everything to that 88.5. However, I am going to go ahead and put this length definition into the definition of generate spiral into this tibble that we are going to output. That way we can run generate spiral, and we'll then get back the third column for the length. And so then if I wanted to remove anything, so if let's say I want to do filter length less than, say, 10, I now get 87 rows for my tibble, right? And so then I could then pipe this into ggplot, and I don't have the full coordinate space, but we now see that we have kind of a shoulder, right? We have basically like 45 degrees of our spiral. So why don't we go ahead and make this look a little bit more normal? And we can do that by doing chord equal, and we'll do xlim equals c negative 11 to 11, and ylim negative 11 to 11. And so there we see that top corner, if you will, of a spiral. We now have a couple things that we need to do. So let's start by adding in the other years, and we'll separate the years by some level of thickness that we will fill in by creating the rest of the polygon for each of those years. So I'm going to go ahead and take my generate spiral function, because I think that's probably in pretty good shape, and I will move that back up here to the top. And then, of course, we have our tribble that has the years as well as the value. I don't know why I put the value before the year, but whatever. I'm sure you'll forgive me. Let's go ahead and pipe this to a mutate, and we'll say fraction equals value divided by max valuation. And so that should be value, not valuation. All right. Should always go with the shortest word. And so now we see, of course, that the 1899 year, the length of that spiral will be the reference, right? That's going to be a full going out to that 3 pi over 4. And then 1895 will be 0.922 of that, and kind of going back to 1875, which is about 1.5% of the full 1899 valuation. So let's go ahead, and I'm going to call this data. So I think another thing that we want to add is a position in the overall spiral, right? So 1875, if that's our outer radius, that should be 10. So I need to get a position argument, right? We can then define that with row number. And so if we, again, run all this, we see that we have a position of 1 through 6. But if my initial radius is 10, then I want 1875, I want it to be at 10, right? And so what I'm thinking then is that my initial radius, I've got position 1, but I want that effectively to be 10. And then I want this to be 5, right? And so what we could do then is row number minus 1. And again, if we look at data, we see that we're going to have position 0, and we can then subtract position from the initial radius, right? And we can also subtract position from the final radius, right? But that is going to be for a thickness of 1 unit. And so I probably want some control over that thickness. So I'll create a variable I'll call thickness, and we'll say, let's start with 0.5, and let's get some room here. And so then we can go ahead and take row number minus 1 and multiply that by thickness, right? And again, if we have data, we then see that we have 0.5, 1, 1.5, 2.5. That works, and then we'll deduct that from both the initial radius, and the final radius. Now what we want to do is for each row of this tibble, we want to apply our generate spiral function. And so again, let's go ahead and take data, and we'll take that, and we'll then do a mutate to create spiral, and we'll use the map function to iterate over each row separately. And we'll use the position column to iterate over, and then we'll use the tilde generate spiral. And again, our arguments are going to be the initial radius and the final radius. This position is .x. That's the argument within map. So we'll do iRadius minus .x as the initial radius, and the final radius will be fRadius minus .x. And so if we run that, we now see that our spiral column has a tibble of 1,000 rows and 3 columns. Let's go ahead and put this on separate lines so it doesn't go off the right side of the screen. We can then unnest spiral, and then we can pipe this into ggplot. So that's pretty trippy. We're treating all of the lines as one group. If we want it to look a little bit better, we could come in here and we can then do group equals year, color equals year. It's using year as a continuous variable. We could, of course, use as.character around year to treat it as a categorical variable. And so now we see that we have different colors for each of the spirals. A couple weird things are happening here that have me a bit concerned. So first, the lines seem to cross each other in here. And that's weird. And it ends at 0. So I'm wondering if there is a problem perhaps in how I'm defining my position, right? With my fRadius. Oh, I did fRadius equals .x. That should be minus .x. And I think that's because fRadius is an argument, right? And so it populated that for me and then plugged in .x. So we had something weird going on for sure. We now have our spirals behaving like we would expect them to. They're not ending at 0. Wonderful. I'm getting thrown a little bit because 1875 here is the red, whereas with DuBois, it's 1899. So I'm like, wait, we've got the orders flipped. But no, that's right. The next thing I want to do is change the length of each of the spirals to be proportional to the valuation. So coming out at unnest, we have for each year the x, the y, and the length, right? So to scale each of the spirals by the 1899 data, if we take data, then we get this, right? And so we know that the length of the spiral for 1895 should be 0.922 of the length of the spiral for 1899, right? But I don't know that length. So we need to get that length, right? And so let's go ahead and call this value data, and then we'll pipe value data into our spiral, right? And let's go ahead and we'll eventually call this spiral data, right? But we'll hold on to that for now. And so again, if we look at value data, we get this as a fraction of 1899. Let's go ahead and see what the max distances are for each of the years. So let's do a group by year piped to summarize max length. So we see that it's 59.1. So basically we want to multiply 59.1 times all of the other values, right? So let's go ahead and call that spiral data. We don't want to include this other stuff, right? Let's say reference length is going to be spiral data, group by year, summarize max, right? And so then reference length is all that, but we really want to do filter year equals 1899, and then do summarize max length. And so then our reference length is going to be 59.1. We'll go ahead and call this max equals that, and I'll do then a pull on max. So that now reference length is going to be 59.1 whatever, right? Okay, so now we have our reference length. And we can then take spiral data, and again, spiral data has the value, the year, the fraction, the position, and all this other stuff, right? So we can then take the fraction, multiply that by reference length, and then do a filter, right? So we can take spiral data, mutate max length equals, and then we'll say reference length times length, right? And so now what we see is that our max length for 1875, that's not right because we're multiplying length times reference length. And what we want is fraction times reference length. All right, fraction length. Okay, great. So now we see that for 1875, the max length is 0.873. And so we'll see a point here, right? Like at whatever position this is, right? Where the length of the max length is shorter than the calculated length. So we can then do a filter to keep length less than max length. And then we can pipe that into everything else. Now we have scaled the years by the total valuation relative to the 1899 data. Now what we want to do is go ahead and make the polygon. To make the polygon, we're largely going to do the same thing that we have here, but we're going to subtract the thickness. I'm going to call this my outer spiral, and we'll bring that. And then we're going to have, an inner spiral, and it's going to be largely the same syntax that we have here. Okay, and then we need another close parenthesis. So it's going to be largely the same thing, but we're going to subtract the thickness, and we'll go ahead and do that for both radii. Okay. And then we'll unnest a vector of outer spiral and inner spiral, and need two parentheses there. So it's upset because we have duplicated names. We have X and Y for both outer spiral and inner spiral. We can use names sep to disambiguate the names. So let's go ahead and do that. So we'll do names sep equals underscore. So error goes away. And now if we look at spiral data, we see that we have all the same things we had, but now we have outer spiral X, outer spiral Y, and then it's not showing it, but we have inner spiral X and inner spiral Y, as well as the outer spiral length and inner spiral length. Now, to update our reference length, we have our spiral data, and we're going to filter the year, and we're going to want to maximize the outer spiral length. We could do the inner spiral length. I don't think it's going to be that different. So now if we look at reference length, it's still going to be that 59.1. Okay, cool. And so now what we're going to do is we're going to mutate to take a reference length times the fraction and then filter the length. But again, this is going to be the outer spiral length less than max length. And so then at this point, we have our outer X and Y as well as length and inner X and Y and length. And that has been trimmed, right? Now, again, we have the outer edge and the inner edge trimmed to length, but we now need to convert that to a polygon. So geopolygon works by basically connecting the dots, right? So if you remember doing a connect the dots book as a kid, that's what geopolygon is doing. We have 1,000 dots. Ultimately, we're going to have 2,000 dots because we have an outer edge and an inner edge. So if you think about using geopolygon to draw a square, you would start, say, in the upper right, in the way you're looking at it, right? Upper right to upper left, and then lower left, and then lower right. And then the final edge would be connected because those 2 points would be next to each other, right? And so it's going in that order that you give it. But what you'll notice is that everything we have effectively, by this analogy, starts at the right, yeah? So we have an upper edge that goes right, left, and then on the bottom edge going right, left, right? So if we then connect that with geopolygon by concatenating those two vectors together, it's going to go top right, top left, across, bottom right, bottom left, cross, back to upper right. Yeah, so it gets something that looks kind of like an hourglass. To resolve that, we need to take the points on the bottom and reverse them. We can do that by, after doing this filter, doing a mutate where we'll take inner spiral X, and we'll make that the reverse of the inner spiral X. And then we'll do the inner spiral Y being the reverse of the inner spiral Y. And we don't want to do that across everything. We want to do it by year. We can't see everything here, but let's go ahead and maybe clean this up a bit so we can see it. So let's go ahead and pipe this to select, and we'll do year, and then we'll do ends with underscore X, ends with underscore Y, And so now what we see, if I look in at 1875, right, we have x at the top, right? So we have that 10 to the negative 15, and then we have it down here as well, right? And so we basically have these flipped, and then we have the same thing for the y on the right side, right? Like the orders we can see are flipped. Okay. Now what we need to do, though, is bring together those x and y columns to make them in the same column, right? We need to have one x and one y column for each of our years. So to do that, I'm going to go ahead and remove this select, and now I'll do a nest, right? And so we'll do everything but the year, the value, the fraction, and the position. And it's upset with me, because I didn't give a name to my data column, right? So I will go ahead and call this spiral equals everything but those four columns, right? And so now we have value, year, fraction, position, and then we have our tibbles that for 1875 is 8 rows by 7 columns, right? And then you can see that for 1899, we have 999 rows by 7 columns. And that is probably because back here, I did less than rather than less than or equal to, but who cares, right? It's not that big of a deal. Anyway, we'll bring in that 1,000. Good. Now what we want to do within each row of spiral is we want to concatenate those columns to each other. And so we can do that again with mutate and map. And I'm going to call it XY. And again, we'll do map. And the data we're going to give it is from spiral. We're going to iterate over each value of spiral. And we're going to use bind rows. And so we're going to make 2 data frames for each value of spiral. And then we're going to concatenate those together row-wise, okay? So we'll do select on spiral. So we'll do .x. Again, that's the value, the argument value for spiral. And so from that data frame of spiral, that in the first case, 8 by 7, we're going to make a column x, and that's going to be outer spiral x. And then y, that's going to be outer spiral y. Let's go ahead and bring this down a line so we have everything all within one window. And then we'll do another select on .x, and then we'll have the same column names, but different columns, right? So we'll do inner spiral x, y is going to be inner spiral y. And make sure we've got all our parentheses right. And so now when we run this, I must have misspelled mutate. Yes, I think I heard someone say that. Let's go ahead and clean up everything here. Now what we see for x and y is that we now have 2 columns, right? And 16 rows for 1875. And so that's because we had 8 rows, but 4 columns of x and y's. And so then we made it longer. Now what we can do is go ahead and pipe this to unnest, and we'll unnest x, y. And so now what we see is that we have the value, the year, the fraction, the position, x and y. We don't need really these 3 columns of fraction, position, or spiral, but we'll leave them for now. And then we can pipe this to ggplot with x, y group being the year, the color as the character of year. And instead of geom path, what we want is to do geom polygon. And thank goodness it worked. We now see that we have polygons for each of our years. Cool, eh? We gave it color for the line, and the color should be black, and the fill should be the year. So that is a classic Pat Schloss mistake. So here we'll do fill as character, and then geom polygon, we'll do color equals black, and line width equals 0.2. We are going to need to do a little bit of futzing with the thickness and the starting and ending positions to get ours to match kind of the appearance of theirs, right? So like I notice his 1899, again, as we said, ends at 3 pi over 4, whereas his 1895 ends, basically like at 7 o'clock, whereas ours ends at 5 o'clock. So I think by changing that initial and final radius as well as the thickness, we're going to be able to change that appearance. So let's see what happens if we change our outer radius to be 15 and our inner radius to be 10. So this has promise because I see the 1895 is now closer to 7 o'clock. But what I'm seeing is that we turned on the limits for our X and Y axes. So I'm actually going to go ahead and remove these axes now that we have the full spiral, and that looks better. I'm noticing, however, that maybe this 1895 line is going too far to the left, and the same for the 1890. So maybe if we make the thickness a little bit larger, so I think have it at 0.5, let's go ahead and make it 0.6. So I think that's pretty good, although I'm noticing that like the yellow for 1890 is should be right at about like 3 o'clock on a clock face, whereas here it's down a little bit. And in fact, I think over here, the 1890 is a little bit before 3 o'clock. Let's see what happens if we make this 0.7. I think that's good. Let's split the difference and make it 0.65, and I'll be happy with that. And I think that's perfect. We now have all of our spirals ending in positions that look a lot like what DuBois was able to achieve. Awesome. I know this has taken a while. That was really hard. Trust me, it's hard on me. So let's move forward with adjusting the fill colors and cleaning up the appearance a bit before we move and take on our legend. So again, we'll do scale fill manual. So we'll do breaks equals seek 1875 to, I'm going to put 1900. It's actually 1899, but what I'm going for here is an easy way to make 5-year breaks in the years without having to worry about typing it all out by hand. So I'll go ahead and put that to be 5. We can then also say as.character on that vector, right? And then our values, we're going to use as a vector. So 1875 was a pink color, and I have Anthony Starks' style guide up where he gives some hex codes for suggested colors. And so pink is this FFC0CB. We'll plop that in. And then 1890 is the blue. So we'll go ahead and grab that. And then we have a light tan, I'll call it. Plop that in. And then he has the yellow or goldish color. We'll grab that. And then it's a whitish grayish color. And so I'm going to go ahead and put in gray. Let's do 80. Starks doesn't have the gray, so we'll roll with that. And then the final is that crimson, this one here. Plop that in. And it didn't show my 1899 data. I think I got too cute because it is trying to map to the breaks, and the break was 1899, not 1900. So we'll go ahead and make this 1895, and then we'll append to the end of that sequence 1899, and make sure we've got all our parentheses here. I don't know that I saved anything by using that seek function, but there we go. Now we have our colored spirals. That looks good. Let's go ahead and get rid of our legend, which we can do up here in GeoPolygon. We'll do show.legend equals false. And again, that expands it out nicely. So let's go ahead and turn off the expand in chord equal. We'll do expand equals false. So I'm noticing a little bit of clipping up at the top and at the bottom. So let's go ahead and also turn off the clipping. We can do that with clip equals off. Again, clipping is what happens when data falls outside of the plotting window. It will automatically remove that data. If we say clip equals off, then it will show the data that falls outside of the plotting window. And so now we can see the black line right at 0 on the top edge for the 1875 data and for this brown 1885 data at the bottom. Great. Now what we want to do is go ahead and put in our valuation data as well as our years. So the next thing I want to do is add in what I'm calling the legend. And I think I'll do this in 3 parts. So the first part will be putting in the value data, and that's going to be right justified. And then we'll put in the year data, which I think it's effectively left or right justified. And then we'll add a line in between. I think we might actually need a 4th step, which would be to add these double quote marks to indicate that the $ comes all the way down. We'll get there when we get there, but let's start with adding the valuation data. And so we'll do that back up here. We'll do geom_text. The data we want to use is the value data. And then our AES, X, I want to make, let's make that like -1. Y, let's make that I radius minus position. And then our label, we can make value. And we're going to say inherit AES equals false. And we'll add that in. I'm trying to think if we need any other aesthetics. I think that's it. So let's go ahead and give that a shot. So I'm seeing that yes, it did center it on the outer radius. We also need to change the font as well as make it right justified. And we'll have to kind of beautify the font a bit. So let's go ahead and alter the vertical position. That is going to be iradius minus position minus thickness divided by 2. And now that is smack dab in the middle of each of those polygons. Do family for the font, and we'll make it Vasserly. And then we'll do size, let's make that 8, and we'll do size.unit equals PT. Again, that'll be a guessing for the size, and we'll adjust from there. So I think that's a pretty decent font. Things are gonna get smushed in as we adjust the margins. Let's go ahead and make that 7, and I'll leave that as being good. For now, I'll then do hjust equals 1 to get everything to be right justified. Good, so now we have everything right justified, but it's perhaps a little bit too far from the start of those spirals, right? So let's maybe make it negative 0.5. Now we want to beautify the appearance of those numbers, right? And so again, we got that as the value for the label, right? And so I'm going to make a pretty value column. And so that will be in our value data table up here. So let's go ahead and do pretty value. We're going to do format on value. So we'll do big.mark equals a comma. And so let's see what that looks like. Good. We now have that, but we want to get rid of this space at the beginning. To do that, we can do trim equals true. And again, let's go ahead and see what that looks like. Good. We now got rid of that leading space, but we're going to want to modify pretty value to add the dollar sign. And so 2 of the years have a dollar sign, right? So the 1875 and the 1880, noticing have a couple of spaces between the dollar sign and the number. And so we'll do if else year equals 1875 or year equals 1880. If that's the case, then we'll do paste 0 and we'll do dollar sign. Let's put in a space and then comma and then pretty value. I guess I didn't need to use paste 0. I could use paste because it automatically puts a space in. But I think by using paste 0, if I want to put in 2 spaces, we can do that, but whatever. Otherwise, if it's not 1875 or 1880, we'll use pretty value. And so that looks pretty good, but if I take this one up all the way, there's not really going to be a space. And I see like a space between the quotes and that 1. So let's go ahead and put 2 spaces. And so now I feel redeemed for using paste 0. So now if I go straight up from this million number, I see that there's going to be a space between that and the dollar sign. Part of the problem here is that our font isn't a perfect representation of their font. But anyway, I noticed that there's an extra space perhaps between the 21 and the dollar sign for 1875. We can very quickly resolve that by coming back up here like we did before, and I'll copy this for pretty value and put in a comma here and clean everything up. And then here what we'll do is for 1875, maybe we'll remove one of those spaces, and down here we'll go ahead and remove 1875. I think that looks pretty good. Great. Now what we want to do is put the year in off to the left. And so I'm thinking that this grid line is 5. And so maybe we want to center our years on 5. So let's come back down into our code here. And we'll do geom text data equals value data. And then we'll do AES. X, let's do -5. Y equals the same thing that we had here. And then our label will be the year. And then we're going to want basically all this other stuff as well. All right. So we'll paste that in. And I think our hjust, though, might want to be 0.5 to center it on -5. Now we want to put in the line connecting the year to the value. And I'm going to do that with an annotate function. And we'll come in here and do annotate. And so then we're going to do geom equals segment. And then we'll have x. And we'll have those start at, let's say, minus 4.9. And then our x end, we're going to have different ending values because our numbers, our value data ranges in length of those numbers, right? And so we went to negative 0.5 and everything is right justified on that. So let's start with like minus 2 and I'll do minus 2 for all 6 years here. And then we'll adjust each of them individually. And then our y, so because I don't have the geom coming through, I don't get position. So our I radius is 15, right? And so let's go ahead and do I radius. So our I radius had a thickness of 0.5, so it went down 0.5, right? And so I think if we do seek I radius 15 minus 0.6, 6 times, but to the top edge, that's like 5 times, right? So that should be to 10. And then we'll go down by 0.6, right? And I see that I miscalculated. I'm not sure what I was thinking, but it should go down to 12, right? So that's the 6th element in the seat going down by 0.6 each time. Could make this like I radius, right? That was 15. And going down, we could then say I radius minus thickness times 5. And it could go down by thickness. And so that way we're not hard coding anything. So we get a different result. And I wonder if my thickness wasn't 0.6, it was 0.65. All right, that's why. See, it's good that we didn't hard code it. This is why you don't hard code things. All right, so that's that. But then we want to subtract half the thickness to get it to be in the middle, right? Thickness divided by 2. And we'll go ahead and close that. And then let's go ahead and add that to the rest of the pipeline. We now have our lines. Of course, they are in the wrong place. So on the left, we need to move that over. I think we made that 4.9. And so this grid line is 2.5, and this is 5. So let's move it to 4. And again, we're gonna have to do some adjusting. Okay, that's too far. Maybe instead of -4, we could do -4.3. Then we're gonna need to move the right edge of our line over. And they're actually going to be different lengths. So let's start with this first one, which was -2. So let's maybe make it -2.5. Bang. Wow, that was good. I did it. And then the others are all going to want to come over the same, right? And so maybe instead of writing this out 5 times, I can do rep minus 3.5 5 times. And that's pretty good. What do you know? Now let's go ahead and make those lines not as strong, right? And so we'll go ahead and I'm going to split this over a couple lines so that it doesn't go off the right side of the screen. And again, that was our Y. So let's do line width equals 0.25. It's maybe too thick. Let's make it 0.1. I think that looks good. Now what we want to add are the quote marks under the $sign. And I didn't put those into the numbers themselves, into that string, because we don't have a fixed width font, right? And so I think it would just be horrible to try to position quote marks for these 4 values by adding spaces. And ultimately, I think it wouldn't really look good anyway. So let's add that with geom text. So let's do another annotate with geom equals text. And then our x, let's make it not -2.5. Let's make it maybe -2.6. And then our y is going to be the same thing that we had here. So let's take that and plop that in. And then we're going to want all of the same font information that we had before, although we don't want that HJust of 0.5. I think that's actually the default anyway. So let's go ahead and remove that. And then we need a label. And I think we need 2 backtick escape characters to get a double quote. And then we'll go ahead and put a comma in there. And then we need a plus at the end of this. And it is not happy with me. Unexpected token quote. And so I think a better solution might be to use a single tick around the double quote. And what I'm seeing is the backslash, and I'm seeing it is way too far to the right. Of course, that's 0.25, and I put x at negative 2.6. And our line went to negative 3.5. So that's probably what I wanted, was negative 3.6. And I was seeing the backslash show up, so let's go ahead and remove that backslash because we don't need to escape it, I don't think. All right, so there's our tick marks. And so let's move it over to the right just a smidge. And that's negative 3.6. Let's try negative 3.7. And I actually moved it to the left more. I'm getting tired. Negative 3.4. Okay, let's do negative 3.2. And I think that is pretty well centered under the dollar sign. Maybe it could go to negative 3.15. I don't know. That's perfect. But now we have tick marks for 1875 and 1880. So we'll want to remove those. And so our label then, we'll do C, empty, empty, and then we'll want to repeat this double quote 4 times. And so now what we see is that we have those tick marks to the left of the value data for 1885 through 1899. And we have our dollar signs. This is looking good. Now we want to clean up the appearance and get our title. So I'll go ahead and copy the title, and then we'll come over here and do labs. The title equals that. I'll go ahead and put in a \n to get the title to go over 2 lines. And we'll also do x equals null, y equals null. Now we need to go ahead and get rid of the axis, ticks, and text and change the font of the title. So with that, we'll use my favorite function, theme, and we'll do axis.text. Or just, we don't need to do .x, we can do all of them, equals element blank, axis.ticks equals element blank. And then we can also get rid of the grid lines by doing panel.grid equals element blank. Cool, that gets rid of all that extra stuff. We also need to get rid of the background. We can then do panel.background equals element. We can do blank, yeah. That makes the background transparent, the same color as the background of the overall plot. Cool. Now let's style up the title. We'll do plot.title equals element text. And we'll then do family equals B52. And my experience in the past says that we want the size to be 12. Yeah, that's pretty good. Now let's go ahead and center justify that. So we'll do hjust equals 0.5. And now we have the problem that we've seen in the past with chord equal, where our margins do funny things. So let's go ahead and start by bumping up the bottom margin on the plot. And so we'll then do plot.margin equals margin. Let's do b equals 30. So that moves that up. Let's keep going, maybe up to say 60. Good, let's keep going. Let's maybe do 80. Good, I think that's good on the bottom. And so now let's bring it in on the sides. We'll do L say equals 30, R equals 30. Perhaps could come in more. Let's go ahead and move the title down. So for that, we could do margin equals margin, T equals, let's say 20. That brings it down nicely. But then we also want to add a margin perhaps to the bottom of the title. And so then let's do B equals 40. And that just snaps it right into place. That's so cool. So I'm noticing it did funky things to my legend here that I am not happy about. Let's go ahead and move the years to the left ever so slightly. I think we had that at -5. Let's maybe put it to -6. I think that's an okay position. So then we're going to want to adjust the lines over 1 unit, I think. And so again, we did that with annotate here. So let's do -5.3. Maybe that's too close now. Maybe instead of -5.3, we make that -5.1. And I think that's good. And then our lines need to end to the left of where they're currently ending on the right side there, right? Let's maybe make this -2.8. That could maybe go to -3. I think that's a good placement. We then need to clean this up a little bit. So let's maybe make this go to like -3.8. Maybe a little bit more. Let's maybe make that -3.9, and I think we'll be good. And now our tick marks need to move over to the left as well. And I probably should have been keeping track of what we're moving these to. So let's maybe make this -3.8. Okay, that's better, but needs to go back to the right a smidge. Let's maybe make it -3.7. Close. Let's do 6. and we'll probably be good. All right, we can make it negative 3.65. I know it's not quite perfect. So I think that looks pretty good. Again, this is an illustration of how when you change the margins, everything else can change, and that is a bit of a headache. Anyway, I'm really happy with the way this turned out. Let me know what you think. Did I miss anything obvious in kind of the sizing of things? Perhaps the spacing between the spirals is a little bit off. We could adjust that by, again, changing our thickness as well as the final radius to kind of bring things in a bit. I'll let you play around with that. Actually, who am I kidding? I'll probably play around with that before I post the code. Again, if you want to get any of the code that I wrote today, go down below in the description for today's episode, and you'll find a link to a blog post that you can go to and get all of the code that we generated. Again, I think this is a really cool, funky plot. I'm glad to have had the opportunity to recreate it with you all here in R. Let me know what you think. Let me know your interpretation. I'm curious about why it perhaps went inwards rather than outwards. I think, again, the practical element of it going outwards is where do you place that legend? But on the whole, I think it's really cool. I think I did a fairly decent job of recreating that. Again, it is a pretty iconic figure, so much so that Battle Baptiste and Russet put it on the cover of their book, describing the whole collection of visuals that DuBois and his colleagues from Atlanta University presented at that 1900 Paris Exposition. Well, again, I hope you enjoyed that. Please tell your friends what we're doing here on Code Club, and I'll see you next time for another episode.